We'll have complementary oxygen set up top very soon, up in the high altitudes. It's time. Let's do it. Hi, folks. Thanks for joining me. Let me tell you what this is all about. This is all about clusters. Windows clusters have existed since 1998, codenamed Wolfpack. It's one of those products where the beta name is more interesting than the product. And so, but here's the thing. How many of you have ever built or looked at a Windows cluster? Okay. Let me see if you're, so I'm going to say prior to 2012, prior to 2008 R2, clusters were expensive and they didn't deliver that much. And so more of you raised your hands than I normally see. Most people are like, no, I ain't doing that. The point of this talk is 2012 changed things. 2012 R2 makes it even better. They become cheaper, more reliable, etc., and they make more sense. Therefore, you could be forgiven if you'd been an IT pro for the last 20 years and didn't know much about clusters. This is a catch-up. By the time you get out of here, you will know the terminology, and I'll have you pointed in the right direction to build your first Hyper-V cluster. I'm using Hyper-V as an example, but that's just because it's the thing Microsoft is most interested in. So we're going to do an overview on the clusters. We'll talk about the tug. There's a tug of war, the yin and yang of clusters, reliability versus safety. Then we'll talk about shared storage. It's something that we have to have in a cluster. It's awesome now. You get not one, not two, but three options, and two of them are quite inexpensive, quite cheap. We'll talk about the steps of building the cluster, and that will be my excuse to explain things to you. Things like witnesses and active-passive versus active-active clusters. So our notion here is that I have something that I want to be reliable. I've got a file share that can never go down. I've got a SQL database that can never go down. I've got a bunch of VHDs, a bunch of virtual hard drives, virtual machines built off VHDs that can never go down. I've got a DHCP server that can never go down. As a matter of fact, you can even cluster WINS servers. I knew you'd be happy about that. If you want something to really, really be reliable, what did we do in the old days? Well, in 2004, the boss would say, let's go to HP, let's go to Dell and buy the most reliable piece of hardware we can. Dual power supplies and this and that and the other thing, and we vacuum it out every month. That's called gold-plated hardware. The alternative instead, with clusters, is we don't buy one really expensive server, we buy a bunch of cheap servers and have them watch each other. To explain that, let's think of this in terms of bookkeeping. We got any accountants in the room? Any bookkeepers? No? Let's talk about them, okay? Do you trust your accountants? I say, I can't hear you. Do you trust your accountants? You think so? I'm going to say this. This is like clusters, really. First of all, most of them are trustworthy. Let's just say that 90% of accountants are not criminals. If any of you are married to an accountant, this is just a number. I just need a number, okay? So, if you hire an accountant, one accountant to do your bookkeeping, you have a 10% chance of node failure. You have a 90% chance of uptime, in other words. How many nines is that? That's 1 9. Not impressive. So what do? I asked you the question, do you trust your accountants? And the answer is no, of course you don't trust your accountants. That's why you get a second set of accountants called auditors who check their work. Do you trust your auditors? Do you trust your auditors? Hint, they're just accountants. But here's the idea. The idea is if you got one accountant, you have an expected uptime of 90%. Now, if you get a bad accountant, that's in the 10%, when you bring the second accountant in, what happens? Will that second accountant find the mistakes? You have a 90% chance of that. So with one computer, 90% chance of uptime. With two computers, one to back up the other, that second one picks up the 90% of the 10%. And as a result, we have a 99% uptime. Does that make sense? Take it a step further. Could we make it better? If we add a third accountant, what's our uptime? It's not 90, it's not 99, it's 99.9. Now we start playing the nines games. Making sense? That's the idea with clusters. We do not think that we can never create 100%. But we expect that by adding machines that watch each other, we're in good shape. Here's a basic prototype of what clusters look like. Let's say it's 1998 and you're my boss. And the boss says, you know, I went down to the hotel downtown and Microsoft had a presentation and they fed us lunch and alcohol. And they said there was this cluster thing that was awesome. So what are we going to do? I say, boss, I'm on it. So here's what I say, boss, we're going to have a highly reliable file server. We're going to get this server here. That server here, it's going to be a good machine, powerful, lots of space. It's going to be groovy, okay? Going to cost $30,000. This is 1998, top-of-the-line servers. Okay. Boss says, all right, that's good. We're buying a, yeah, I've seen expensive servers before. Good. He says, what else do we need? And I say, well, we got to buy a second one that's exactly the same as this one. Exactly the same. You say, okay, what's that second one going to do? And I say, nothing. Now, what? I didn't hear you. It does nothing, boss. What do you mean it does nothing? It's $30,000. Well, see, this guy's job is to wait for this guy to die. This guy does all the work, and this guy goes, However, these are big servers, boss, and we're in Oslo, where it's cold in the winter, and those servers can help heat the building. So we'll save some money there. So you say, well, do we need anything else? Yeah, we do. We need that thing. We need a SAN. Okay, it's 1998. We don't have SANs yet. We had these big scuzzy towers, but same thing. What's that going to cost? About dollars. And so that's even more. We moved fast forward to 2004, where we could spend $100,000 on a SAN, $70,000, $50,000 very easily. What's the purpose? The purpose is we can't put the files here because that guy could go down. We can't put the files there because that guy could go down. We put them in a central location. That's the basics, yes? Let's look at it in greater detail. We start off using cluster terminology. If we're going to do a file server cluster, we want two identical file servers. If we're going to do a Hyper-V cluster, we want two identical Hyper-V servers. If we're going to do a DHCP cluster, we want two identical DHCP servers. If we want to do a SQL cluster, we want two identical SQL servers. Making sense? They got to be able to do the same things. But we don't store data we care about. By the way, the term is nodes. Those are called nodes. That's an unfortunately overused word, of course. We then have our central location, our shared storage. Shared storage means something. When I hear shared storage, that sounds like a file share to me. It's not. It's more than that. And we will talk about what that is in just a minute. The important thing is that's where the data you care about goes. This is one of those put all your eggs in one basket. That's an English phrase. I don't know if you guys have it. But put all your eggs in one basket and then guard the hell out of that basket. That's the idea. That's the idea. Or we can get fancier, and that could be a cluster, but that's another story. Shared storage is holding the shared stuff. Now, here's the important thing. This is a bunch of hard drives, but they can be spoken to by this guy and this guy at the same time, at physical block level, sector level. Thus, it is theoretically possible for this machine and this machine to write to the same space. That would not be good. One of the servers does the work. The rest of them just sit around waiting. This is called active-passive. HV1 might be my active file server. HV2 could be my passive file server. You can have as many passives as you want, but all they do is just sit there and heat the room. Okay? So questions on this, anybody? All right, good. As I said, we were talking about clusters now because when we did this in 1998, when we did this in 2004, first of all, it was witchcraft. It was hard to make everything work. If any hardware problems existed, it would just plain die and not tell you much. Okay? There were also exchange clusters. They were a little bit different. So they were hard to set up. And also, if this were my file server and I were connected to that, this is in 1998. So I'm pulling files off this thing. I'm net using to something. And I pull the files off here, and this machine dies. I don't know as the user, but my machine is switching from here to here. That's called failover. When one node dies and we move over, that's called failover. Failover is not instantaneous. In 1998, it could take 45 seconds or a minute. So failover could take some serious time. As systems got faster, as networks got faster, those numbers have gotten better. But understand, this is active-passive, which is what 90% of the clusters you can do are still to this day, and that there is a visible failover time. That making sense? Questions, anybody? All right, good. 2008 changed things. It gave us a nice wizard that made life easier to do things, made the networking easier. 2008 R2 bumped things up and gave us a big quantum leap, an important quantum leap for Hyper-V clustering. 2012 made everything cheap. There were some nice improvements, but mainly 2012 took the expensive stuff. I mean, SANs are so expensive that even looking at a Windows cluster has always been a big check. 2012 changed that. And 2012 R2 bumped things a little bit more. So that's why I want to talk to you about this. The pieces, we've talked a bit about them, but let's just underscore that. 3 things we need to make clusters work. Nodes, these are identical servers, all running the same function. Making sense? They do not store anything. I mean, they've got a local hard drive, but they're not storing anything. We need a shared storage. There's 3 ways to do that. And then finally, the software that's running on that cluster must understand clustering. Simply plugging in SQL Server database software is not going to build you a SQL cluster. You need to buy the enterprise SQL, the expensive SQL, where they made it a little smarter. With Hyper-V, excuse me, that used to be true with Hyper-V as well. You used to have enterprise Windows Server, which means when you'd say, Mark, what are we going to have to buy? I'd say, by the way, boss, you know how we've been buying that standard server that's $1,000? Yeah, now we got to buy the enterprise server that's $4,000. And you say, why? I say, because the first one won't do clusters anymore, ever. 2012 changed that. Okay, nodes, software, nodes, shared storage, software. Questions, anybody? Okay, good. All right, so shared storage. The notion is where our shared data lives, and it's almost like, essentially think of it this way. Think of it as you've got 2 computers connected to the same drive, and they can write to the same drive at the same place at the same time. What happens if I have 2 computers that write to the same sector of my hard drive at the same time? Is it good or bad? It's bad. If it's just a data file, I may have ruined the data file. If they're both trying to write to the super block or the spare block, the bitmaps, or the root directory of NTFS, I may blow up the whole volume. So, why are we doing this shared storage? Because it's fast. But what's the bad news? The bad news is that if it goes wrong, whoom, we lost some data. Maybe lost our SQL databases, lost our virtual machines, etc. So a big part of what clusters do is we got 2 servers that are both touching the same thing, so they're dancing. But we've got to make sure that they dance so they don't step on each other's feet. And that's a lot of what cluster software does. Okay so far? So shared storage, fast, simultaneous, block level, but dangerous. We need software to keep it from clobbering data. Which leads to what I call the goal versus the prime directive. Our prime directive, we want reliability. I want that Hyper-V server up 24/7. And clusters give us reliability. The problem is, though, that clusters need shared storage. And the problem with shared storage is that if things go wrong, we could lose all of our data. So we have very reliable data, but it gets destroyed now and then. I mean, that would not be good. And that's why the way this works is that the goal is I want more reliable whatever, more reliable Hyper-V, more reliable file server, whatever. But the prime directive says, don't toast my data. Don't destroy my data. So our goal is always, how do we get that higher reliability, more nodes, better software, etc., more networking hardware, whatever. The prime directive says, but be absolutely sure you don't corrupt anything. Questions? You guys are quiet. Are you getting this? Okay, good. Thank you. So you see that we're mostly talking about reliability, but we'll step in with the prime directive now and then. Another concept on clusters. The other concept on the clusters are the names and the IP. Imagine that this is a file share cluster. I have two, what are these called? Nodes. They're running the same software. Their names are, something like whack whack FS1, whack whack FS2. Remember we used to say backslash? We used to say backslash, backslash FS2, backslash, backslash. And then one time in 99, I heard this Microsoft guy at a presentation just say whack whack. I said, whoa, 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 what's that whack? He says, whack, backslash. I said, so a backslash is a whack? He says, yeah. It's one of these things at Microsoft where a new word appears and everyone at Microsoft knows it immediately. And then when they get to talk to us, they're like, you don't know that? How could you not know that? So I said, so if a backslash is a whack, is a forward slash a back whack? He stopped taking my questions from then on. So the way these guys are working here, now, and we have some shared storage. Now, you've all done a net use. If I'm the client over here talking to those guys, do I say net use G : whack whack FS1 or whack whack FS2? That's not going to work because I don't want to know the details. It's like legislation and sausages. You don't want to watch them being made, So what do I call it? What do I connect to? Whack whack FS1 or FS2? Here's what happens. Oh, by the way, notice I've got an IP address here, IP address here. Here's what happens with a cluster. We create an imaginary name for an imaginary computer. I called it cluster 1. You could call it anything. And we give it an IP address. Notice that neither of these guys have that IP address. So when you build a cluster, you are assigning an extra IP address, and you're creating an imaginary computer. You'll actually see it in Active Directory. It'll have a machine account. So not just FS1 and FS2, there'll be cluster 1. We then attach to whack whack cluster 1, not whack whack FS1. Make sense? Questions? That'll be important for setup in a little bit. As I think I've said, I have a lot to do in 60 minutes. So I'm going to focus my examples on Hyper-V because that's what Microsoft's pushing. Basically, if you were with me yesterday, I talked about how Server 2012 really has just one job. It is a finely honed missile. It is a destructive missile whose job is to destroy VMware. Because 2012 makes the shared storage get cheap. 2012 makes the software cheaper. 2012 makes the networking cheaper. So when you look at the bits and pieces of building a VMware cluster, I got no problem with VMware, it's great stuff. I don't work for Microsoft, I'm just telling you what they're up to. And what they're trying to do is they're trying to make all these pieces so cheap that you migrate from VMware because it's so much cheaper. What did Ben say last night when somebody said, what's the reason to go from Hyper-V, from VMware to Hyper-V? And he said, ultimately, we're cheaper and we do everything they do. That was Ben as a Microsoft, and he's pretty much right. I mean, it's just, they've done some cool stuff here. All right. So to set up a cluster, we're going to set up two near identical machines, create the shared storage. We'll see how to do that. We haven't talked about this yet, but there's a thing you need called a witness. A witness is there for the prime directive. It doesn't give you reliability. It keeps your systems from destroying each other. We then test the cluster. There's a wizard that will test it for you. Once we've done there, we build the cluster, and then we cluster something. We cluster a virtual machine. We cluster a file share. We cluster a SQL database. Those will be our steps, and I'll explain all of these things to you. So step 1, let's see how to set up nodes. If we're talking Hyper-V, 2 machines, you want the hardware as close as possible. Can you cluster 2 different machines? Absolutely. You cannot cluster different architectures. You can't have an AMD box and an Intel box in your cluster. Not yet. I think one day you'll be able to, but you probably don't want to because the performance would suck. You'd have to dumb down the CPUs so much, you'd be losing a lot of what you paid for. Get these machines, install server, Same copy of Windows Server. Standard Server will do it. Enterprise doesn't exist anymore. So the $800 version of Server will do the job for you very nicely. Join these machines to domains. I do not know how to build a Windows cluster without a domain. So join these machines. They must be member servers. They cannot be domain controllers. They cannot be domain controllers. So you're going to give them different names, different IP addresses, but same roles. And as with everything Active Directory, check DNS 3 times. Okay so far? Next, you're going to put network. You could put one network card on your node. You probably won't. You'll probably be adding extra NICs for extra functions. It's not required, but for performance sake, you're probably going to think about it. Remember, the nodes cannot be DCs. Do not attempt. Can you have a domain controller? Sure, you can, but it cannot be one of your nodes. It will not do that. You then need a cluster-friendly operating system, which we have, and make sure that your application software is, again, cluster-friendly. That's going to be the stuff we've already talked about. Then you install a feature, not a role, called the Failover Cluster Manager. It comes with a GUI that looks like that, and it's a little wonky, but if we look a little closer, then you can see here's some cluster I've created called VM Cluster 1. And first of all, it's got roles. Roles are what am I going to cluster? A file share, a DHCP database, a virtual machine. And then nodes. I've got 2 nodes. In my example, my nodes are called new and old. Instead of FS1, FS2, I call them new and old. They live in a domain called apple-orchard.net. Clusters care about shared storage. That's what that area is for. Clusters care about networks. That's what that area is for. So we'll see more of the FCM in a minute. Any questions, anybody? We doing okay? Good, thank you. All right, now let's create the shared storage. How do we do this? The traditional way to have 2 servers talk to the same storage at the same time, the traditional way to do it is to get a SAN. Storage area network product of some kind. Typically, how many of you ever set up a SAN or work with SANs? So a lot of you, okay, good. Let me just toss out a term for the couple of people who haven't. SAN storage area networks, they're typically boxes running some kind of Linux with space to stuff a lot of drives in them. They have high-speed Ethernet connections, one hopes, on them, and some kind of brains. The way you communicate with them is through fiber channel and or iSCSI. Windows learned iSCSI in Server 2008 R2. You can always add third-party software. As of 2012, it's quite good at it. So the first thing you can do is that you can use an iSCSI SAN as your shared storage. That's A. B is you create something called a storage space. I'll talk about storage space in a minute. You need Server 2012 to do that. Third possibility, a regular old file share. A regular old file share. So iSCSI, which is the SAN, traditional way to do it, a storage space, I will show you in a minute, or a regular old SMB share. So let's talk about creating storage spaces. Storage spaces is Microsoft's word for their SAN alternative. What they're trying to say to you is get some cheap hardware, get some cheap drives, put Server 2012 or 2012 R2 on it, do some stuff, and you have a SAN. It speaks iSCSI, it speaks all the usual protocols. You take the drives, you create things called storage pools. Maybe you've got 80 drives. And you lump them all together using a GUI or PowerShell, and you end up with a pool of data, like a cloud of data, that you can then carve chunks out of and hand it out. From there, once you created this pool, you carve it up into a chunk. Microsoft calls them virtual disks. Some SAN vendors do. Other SAN vendors call them LUNs, L-U-N, LUNs. And then make sure you match the server versions. Here's a picture of how that would work. You go out and buy a JBOD. That's a device with no intelligence. It doesn't have any computers on it. All it is a bunch of cabling. It's a box where you can stick drives into all those little holes. Many of them will take SAS drives or SAS drives or SATA drives. In simple storage space, you've got to use SAS drives. And why? because those drives need to be able to talk to more than one computer. SATA doesn't know how to talk to multiple computers at the same time. You have to add stuff to make it do that. So we got a bunch of SAS drives in this relatively cheap box. We then have a SAS cable and a SAS cable. JBODs can be found on all stripes and sizes. It is fairly easy to find a JBOD that you can hang 2 SAS cables on. I have seen ones with 4, and I'm told that people sell larger ones. This box I'm thinking of here is something in the $3,000 range. So not a lot to get started. Stuff it with drives, connected to a couple of computers. And at this point, you then run storage spaces. This is going to be 2012 or later systems. And you can then say, hey, let's take all these drives, let's make them into a single storage pool, and then carve it up into LUNs, which we can then hand out and can be shared by these Hyper-V servers. This clearly is a simplified picture. We okay so far? That's storage spaces. Third possibility, which is really cool, the third possibility is that you could just create a file share. This is wonderful. It's wonderful because if you have never built a Hyper-V cluster, I really hope to convince you to give it a try, because it's pretty cool. You can very easily test what these things are doing. It's easy to find a couple of old servers to put 2012 on, right? But I mean, who's got an extra SAN lying around? Well, most of us don't. All you need is a third box, set up a file share, just do net use from both of these guys, and you're in good shape. So it's cheaper than a SAN. The way Microsoft's got it set up, you may have a better failover time, and we'll see some of the details about it. Again, I would never put that in production. One simple file server with a couple of Hyper-V boxes, I'd never put that in production. But to play around with this stuff, it's the easiest thing. You don't have to learn anything new. It's things you already know. The file server can be a? Yeah, oh, absolutely. No, all of these servers can be virtual machines. If you're running, for example, VMware Workstation, it has a feature that they do not support but works, where you can actually build Hyper-V boxes virtually, and the guy in the middle. So I mean, yeah, absolutely, those guys can be virtual machines, no question about it. In the real world, you're gonna, it depends on how you're gonna lay out your data center. Good question, thanks. All right. Now we've got things in place. We've got our nodes built. We're connected to a domain. We're connected to our shared storage. Let's see if this is going to work. Now, back in 1998, back in 2003, back in 2007, if you built a cluster, if you got anything wrong, it would just go and not work. With 2008, actually I think in 2007, Microsoft let you download a wizard you could add to Server 2003. But 2008 was the first version that gave us a nice wizard that would double check that all the magic was working. Gives you a nice big long HTML message about, HTML report about how this works, that's not working, etc. Now, you can certainly do this with the wizard, but the PowerShell command is so simple that it's just crazy not to use it. Again, in my examples, I've got 2 nodes, one named old, one named new. They're in a domain called apple-orchard.net. If you want to test them and create a report, it'll produce a report. And let's say you want to put that in the root as c:\cluster report.mht. You can't control MHT, so that's what the command looks like. Test-cluster, old, new. What are we doing? It's a comma-separated list of the nodes, the machines you want to make into nodes. Dash report name, c:\cls report, and it will add the MHT for you. You guys are going to get these slides afterwards. My understanding is they're going to put them on the NIC. I mean, go ahead and take a picture. Go ahead and take pictures of any screens that you like, but you will get these slides. Okay? So questions on that? That doesn't look hard. People say PowerShell's hard. It's not hard at all. Heck, there's less typing than the click, click, click for the failover cluster manager. Now we're ready. Any questions on this? It'll tell you things like your network's not going to work. Or maybe it'll say, you know, you've only got one network. You should have an extra one for failover. Because if you think about it, that's true. The networks that are connecting these guys, why have just one cable and one NIC? Many people will spend some money for an extra cheap NIC, bam it on in there, and it's the backup NIC in case the first one fails. And you know what's great? All you have to do is plug the NICs in, and that's it. The cluster software just figures it out. Now we can build a cluster. To build our cluster, what do we have to tell it? Tell it the nodes once again. But now we're going to have to give it a name, because clusters need a name. And remember, it needs a static IP address. That's what PowerShell would look like there. New dash cluster, dash node, old, comma, new. So those are the nodes. Dash name, VM cluster 1. Here I'm going to call my cluster VM cluster 1. Whack, whack, VM cluster 1. Dash static address. And that's how you do it from PowerShell. I know PowerShell is complicated. Instead, we can do it with the wizard. Are you ready? You start off with the wizard, and the first page, it's a rule. The first page in every Microsoft wizard doesn't do anything useful. Okay? It's the useless page. Then we go to the second page. Second page says, what are my nodes going to be? Just include the nodes. There's new and there's old. Questions on that? If you guys can't see that in the cheap seats, there you go. Then at that point, it wants to know a name and an IP address. So I got to fill in a name here, and over here I've got to fill in an address. I do that. I'm now ready to go. Then there's a page that says, are you sure? I'm glad they do this, because you're probably like me, you know. If it's a Friday night, you're probably sitting at your server, keyboard, bottle of tequila, just typing away random stuff, you know. And without even thinking about it, you start up the cluster manager. Oh, no. Thank God it said, are you sure? Because, I mean, man, that can be pretty messy. It thinks about it for a while. Actually, this thing goes, it immediately does this, and then it goes like and then zip, and it does that. So just it's a good thing Microsoft doesn't make clocks, you know. How long are we going to be there? A million hours? Oh, no, wait, it's 1,000 hours. 2 minutes. Oh, we're here. All right. Now, we have to worry about quorum. Quorum is about the prime directive. Quorum is about making sure that our two nodes don't step on each other's feet while they're dancing and clobber our data. Okay? So, let's think about how, well, let's see. How do we know if I'm a node and you're a node? Let's say I'm the passive node. I want that job. Let's say you're the active node. You're doing all the work. I'm just sitting there waiting for you to die. Is he dead yet? No. Is he dead yet? No. Is he dead yet? No, it's just Saturday. You know, so how do we do that? What happens is we have two nodes, let's say HV1 and HV2. And they send each other heartbeat data. Originally, you had to put in a separate set of NICs. So you had like two expensive NT4 Enterprise Edition systems, and you had to put in extra NICs just so I could say, hi, Node 2, how you doing? Doing well, Node 1, how are you? Very well, thank you. And how are you feeling now? I'm feeling quite well. And this back and forth communication had its own network, which made some sense because, you know, it's a 10 megabit connection. We're running, what, 16 megahertz processors. So, not gigahertz, you know, megahertz. And then what happens is if HV1 is let's say HV2 is active. And I'm HV1, I'm just saying, are you dead yet? No. Are you dead yet? No. Are you dead yet? No. Are you dead yet? Are you dead yet? 5 times. If I miss 5 heartbeats, all of a sudden, I go from Clark Kent to the other guy. I reach over and I grab the stuff. I'm like, don't worry, citizens. HV1 has died, but HV2 is here. And it's automatic. Boom. Failover, very nice. Does that make sense? Yes? So the working thing is saying, I'm alive, I'm alive, I'm alive, I'm alive. Meanwhile, this guy's saying, I didn't hear I'm alive. And it takes over. That's cool. That's what clusters are supposed to do. Here's the problem, though. What if I'm the sleepy guy, and here's the active guy, And he's fine, but the wire falls out with the heartbeat. So the NIC that's going, I'm okay, the NIC, the cable's falling out. This guy thinks I'm dead. This guy has no idea there's a problem, which means this guy is still writing to the shared storage. What's this guy going to start doing? Writing to the shared storage. Uh-oh. This is good. This is known as the beginning of a bad day at the office. Like, how come the orders aren't going out? Because we lost the SQL database. That can happen. It's called a split brain cluster. And it almost certainly leads to corruption. So again, what are we trying to do? We're trying to create reliability. That's why there's me and my partner me. That's reliability. The concern is if the two me's start scribbling, we're in trouble. Now it's time for the prime directive to kick in. The idea is that our goal is reliability, but the prime directive says don't destroy the data. Quorum serves the prime directive. It's the extra belt and suspenders to make sure that we're not going to clobber data. And here's how it works. It's a little bit of extra. There's different ways of doing quorum. Node majority is the default. Let's explain how that works. So the idea is if you have an odd number of nodes, they've got heartbeat. So there's the heartbeat information that's going around here. I got 3 Hyper-V nodes, HV1, HV2, HV3. Here's the rule. If there are 3 nodes, what's a majority? 2. Everybody has to hear 2 heartbeats or more. If everything's fine, HV1 hears its own heartbeat, here's HV2, HV3. HV1 says, okay, I hear 3 out of 3, cool. HV2 says, I hear my own heartbeat, I hear the other 2 guys, I'm cool. HV3 says, I hear my own heartbeat, I hear everybody else's, everything's cool. That's the way things are supposed to work. What are we going to do? Maybe HV3 has a problem and it doesn't know. We use Quorum so that every node can say, uh-oh, I'm not stable, I'm stepping out. Let's say, though, that we lose HV3's heartbeat. HV3 is fine, but the cable fell out. So what happens? HV1 hears its own heartbeat, here's HV2, 2 out of 3, that's good. He says, I'm good, I'm staying. Has everybody got this so far? Okay, good. What is HV2 going to hear? Good or bad? How many of you say HV2 is going to be happy? Come on, talk to me. How many say HV2 is not going to be happy? Okay. HV2 hears 2 heartbeats. It is going to hear HV1 and itself says, I'm happy. What's HV3 going to hear? How many heartbeats does HV3 hear? Just 1. So now HV3 says, I hear what? Oh, 1. Oh, that's not good. He says, I know I'm feeling all right, but they don't, so I just step out. Nodes step out even if they're working because we're being 100% sure we're not clobbering the shared storage. Good on that? Questions, anybody? That's the big concept. Good concept. If you guys all got it, thank you very much.
How would this HV3 knows how it would communicate with the other nodes?
Okay, so
If the heartbeat is down.
So if the heartbeat's down, what does HV3 actually do? HV3, because it's not connected to the other guys, it can't hear their heartbeats. So HV3 is saying, I don't know what's going on here. But just in case, he's still running. But you'll get an administrative message. It's not going to be doing SQL. It's not going to try to fail over. Okay? That's the whole plan. That's the whole plan. Cool. That was a 3-node cluster. Guess what percentage of clusters in the world are just 2-node clusters? Starts with a 9. I don't know the actual number, but I would be willing to bet that except for a few fairly large companies, most clusters are just two nodes. And the problem with 2 nodes is you can't have majority, can you? So what you got to do at that point is that if I'm a node and you're a node and the cable falls out, you can't hear me, I can't hear you, But I've only got 1 out of 2. That's not a majority. You've got 1 out of 2. That's not a majority. So we both say, the heck with it. Let's just not have a cluster anymore, and we stop working. That's not going to be good. So we need a tiebreaker. The tiebreaker is node 1, node 2, and there's like another machine somewhere else that there's a file server share on it. When I'm, as a node, hear only my own heartbeat, I say, you know what? There's only 2 of us. I got to check if I'm still alive. So it tries to reach out and lock that file share. Tries to reach out and lock that file share. At the same time, the node over here says, I'm still alive, but I can't hear the other heartbeat. I wonder what's going on. There's only 2 of us. I'm going to reach out and try to lock that file share. So they both reach out and try to do it. In other words, it's a race. The first node to lock stays in the cluster. The other one steps out. And then at that point, the administrator comes in at some point and says, hey, there's a problem, and fixes it. But the point is we're still up and running. Make sense? We need an external place. Could be a file share. It could be an iSCSI LUN. Either of those would work. This is, again, a mildly weird concept. Want to make sure you guys got it. Yes? We're happy? All right, good, good. By default, the way we do quorum is node majority. Node majority only works if you are an odd number, though. In order to change from a node majority to this extra thing, which is called a witness. Say to any cluster administrator, can I get a witness? He'll hit you. And so you do that with PowerShell or the GUI. For example, the PowerShell is very simple. Set/cluster quorum -cluster, that's the name of the cluster, -node and file share majority. That means we're using a file share. Whack, whack, server 1, whack, witness. You don't have to call it witness, but that's what I did. Don't put anything in the witness folder. Don't back it up. Don't restore it. If you use a LUN, an iSCSI LUN instead, you actually get some more functionality, because what happens is if I grab it first, I can write messages to the other guy. So when the other guy comes around and says, oh, damn, it's locked. Oh, look, there's a message from the first guy. First guy says, I was here first. No, actually, they can pass messages back and forth that go into the log and make life easier. How long? How many heartbeats before I decide you're dead? 5. There's a heartbeat every second. There's a heartbeat every second, which you can change these things, but by default, if you're offline for 5 seconds, I assume you're dead. Questions? Yes, please. So if you're going to use a file share for Quorum, should it be highly available? It absolutely should be highly available. I just gave you the simplest example in the world. But so the question is, if you have another file share cluster, for example, that would be a great answer. Okay, so the question is, anything relating to the witness, obviously you want that to be reliable. It's just adding more 9s. Is there ever going to be a way to be 100% sure? There isn't. Every time we add a piece, if we can add extra redundant pieces, that makes life better. I haven't really talked about it, but again, I've talked about putting in just 1 NIC. You could do that, but it's not a good idea. Most people would put in an extra NIC just for the heartbeat. Some folks I've seen put in 2 NICs on each machine for the heartbeat. You could take it up and add as much reliability as you want. That's the cool thing about it. But if you just want to play with it, I mean, just 3 machines will do the job. For production use, absolutely. In production use, shared storage would be preferable, absolutely, as long as the shared storage is built so it's not a single point of failure or something like that. Okay, right? So, to add the shared storage, at this point we've got the nodes working. We've got to connect them. We've got to connect them to our shared storage in some way, and the way you do that depends on the particular kind of shared storage that you're using. If you're using iSCSI LUNs, you have to connect them to the nodes first, and then you can do it through the GUI. If you're using a file server, you don't have to do anything at all. If you're using storage spaces, it's also pretty easy as well. So what have we done? We've got our nodes set up. Our nodes are talking to our shared storage. In the shared storage, we have our SQL databases. We have our VHDs for Hyper-V. We have our files. We have whatever it is that we're trying to cluster. Are we ready? Well, not really. Because what we've done so far is created an active-passive cluster. Everything I've described to you so far is, again, a model where one machine does all the work. I've got other nodes, and what are they doing? Sleeping. That was the case until 2008 R2. And by the way, for most of the cluster functionality in Windows, that is still the case. There are only 3 cases where you can do better than that. To understand this, though, let's step back and talk about active-passive versus active-active. Okay? And let's see how this is going to work. Basic cluster. To this day, if you're going to cluster DHCP, same answer. I've got 2 servers, HV1 and HV2. I got shared storage. What's sitting in there? In this case, let's make it virtual hard disks. If you are running Server 2008, the best software available from Microsoft at the time, with a perfectly good shared storage device. Now, in those days, 2008, we're probably going to be talking about a SAN, and that chunk of storage you're probably going to call a LUN, because your storage guy or your storage woman is going to hand you a chunk of data called a LUN. All right? Now, what are we going to notice about this? We're going to notice that all of the VHDs, and let's say in this simple world that one VHD, one virtual hard drive, is one virtual machine. So I've got 4 virtual servers, 4 virtual machines running in here. Who's doing all the work? This guy. What's this guy doing? Nothing. This troubled people because they said, wait a minute, why would I set up Hyper-V? Say to the Microsoft guys, have you idiots never heard of VMware? Because in the VMware world, it's way cooler than this. You can have lots of different machines all talking to this shared VMFS, and they can share back and forth. The problem, though, is that the way clustering is being worked in Microsoft is they're being very, very careful. They don't want to clobber things, and that's why it's active-passive. Active-passive was sometimes known as shared nothing clustering. So what was the answer? Well, the answer was really not a great one. The workaround was this. People said, I don't want to have one server that's doing nothing and one server that's doing all the work. So what you do at that point is instead of having one big shared storage, you carve it up into 4 of them. Now this is 2008, when setting up worldwide addresses for fiber cards and such was not much fun. If you said to your SAN guy, hey listen, if you could carve it into a lot of separate little LUNs of a particular size, you would soon find men in black with instruments of death chasing you because your SAN guy would put out a contract on your life. But you could do this. I mean, you know, almost nobody did this. Die-hard Microsoft fans did this, but in general, normal people didn't do this. Okay? But it was an answer. Does that make sense? It's very inflexible, though, because every one of these LUNs has to be just right for that virtual hard drive, and moving it around, resizing it, was a pain in the ass in those days. So it was an answer. So the better answer was that Microsoft changed the way things worked. What we want is to have a single chunk of shared storage. We want to have simultaneous read-write by both sides. Simultaneous read-write by the nodes. And we don't want to corrupt the shared storage. The answer, and Server 2008 R2 introduced this, was called a cluster shared volume. Strictly speaking, you can think of this as a file service like CSVFS. It was an improvement upon NTFS and a step in the direction of what will ultimately become REFS. It had a few things going for it. The basic idea was that you could have multiple servers talking in the same LUN. Let's look at the picture and see if we can make this work. Now I got 2 servers. I've still got 4 virtual machines. But what do you notice? VHD1 and VHD4 are being run by this guy, and VHD2 and 3 by this guy. Okay so far? What was our concern? Our concern was that they would overwrite each other. How do we get past that? Here's the magic. The magic is I just want to make sure that one machine doesn't step on the other one's toes. Well, notice If you have shared storage that has virtual hard drives on it, I'm simplifying, but if you have virtual storage that has hard drives on it, what can we say about that storage? It's a small number of large files. This is a kind of small Hyper-V cluster. But even if it were 16 machines, 16 files, which are 16 hard drives, to drive 16 machines, it's only 16 files. Yes, I'm simplifying a bit. I can assign, and I can say, you only talk to that and that. You only talk to that and that. If we never resize these files, then the chances of us clobbering the hard drive are a lot smaller. Does that make sense? A small number of large files assigned to servers. What's the other application where we do that? SQL. A shared storage with a small number of large files. It's easy to keep track of. You worry about those files, you worry about those files. That's not the whole story. It is still possible that they could write into some NTFS area, part of the metadata, but the solution there was that one of these guys becomes the metadata coordinator. VMware had an easy job because they were trying to build a file system that only handled virtual machines. Microsoft was trying to take NTFS, which was an older, more general purpose system, and add some rules to keep it from bad things happening. So what's our answer? They're both active. If one of these guys dies, the remaining node picks up their hard drives and soldiers on. Making sense? Questions, anybody? So CSV, cluster shared volumes, that is the answer. Now, in 2008 R2 only supported VHDs on CSV. Only supported virtual hard drives on cluster shared volumes. 2012 changed the story because, first of all, it supported SQL. That was important. Clustering support, as I said, went from enterprise to standard. Everyone could afford it. And additionally, there was a third kind of cluster. Not just SQL, not just VHDs, but files, a file share cluster. This is called a scale-out file server for application data. And this is basically, this is the blueprint for the rocket that Microsoft wants you to build to kill VMware with. Basically, here's how it works. It's a cluster inside a cluster. This is that shared storage we've been talking about. This whole thing is this shared storage. Different ways to build it, but let's take this example. With this particular example, I've got two 2012 file servers. They're driven off of a JBOD. We could do it other ways. This is an easy example. So I have the one JBOD talking to the two servers. They're running 2012 server, and they're acting as nodes in a cluster that is a file server cluster. Nodes in a cluster, it's a file server cluster. These guys, now what does this look like to the outside world? We've talked about this before. How many machines does that look like to the outside world? Looks like just one. Its name is not whack whack this guy or whack whack that guy. It's whack whack all of us. Which sounds a little weird, but anyway. So. Then we have another cluster, a Hyper-V cluster. Does the Hyper-V cluster know how many machines there are? No. It just thinks that we've connected to whack whack some cluster name, whack some VHD. So we're providing the high availability here to drive that. And the icing on the cake is that Microsoft did this and said, wait a minute, what's the most important thing you want here? Yeah, you want reliability, but you also want speed. You really want speed. How do you accomplish that speed? A couple of years ago, it would be with 10 gigabit NICs. There's 40s now, but there's another kind of thing called an RDMA board, Remote Direct Memory Access Board. It's like a NIC, but very short distance and cannot be routed. It's basically we just take a cable and pump data across it as quickly as we can. They're a specialized kind of NIC. If you've never heard of it, don't worry about it. No one has. But they've been around for a good long time. It's kind of like back in the old days, we needed to get data from one PC to another really quickly before networks. You put a serial cable or a parallel cable between them and run something called lap link. If you remember that, you're old. But basically, they just max the cable out. It's like, as long as you keep it short, this will work. keep the cable straight, don't bend it at all, you know. This is that version of it. RDMA boards can deliver 56 gigabits per second. And you could put like 3 of them in a chassis. So now look at all those lines, and imagine if these lines are 56 gigabits per second or 168 gigabits per second from the 3 bonding together. SMB runs on top of that stuff. That's the picture Microsoft's trying to put together to challenge VMware. And that's why they made all the cluster software cheap. Making sense? Questions, anybody? And again, that's the simplest example. I'm drawing just one line. In actual fact, there'd be lots of NICs, lots of RDMA boards. This would be something more redundant in the middle, et cetera. Then we need to cluster something. Now we've got it in place. You then run the wizard, and the wizard shows you the things that you can cluster. iSCSI, ISNS, virtual machine, Win server. Again, that made me happy. DTC, et cetera, generic stuff. Those are the kinds of things. So to wrap it up, we get machines, nodes, identical hardware, put the same software on them. Use 2012 or later because it's cheap. It saves you a lot of money. Take advantage of the fact that shared storage used to be expensive. Now it's just a file server. You can try this. Don't do it in production. But you can try this with just a file server that could easily be a virtual machine. A couple of Hyper-V boxes. Tell you a quick story. When Server 2012 was going to come out, everybody knew that it was going to be released on September 4th of 2012. And so the Microsoft guys call me and say, hey, Mark, you know we're going to be releasing Server 2012 on September 4th. I said, yes. They said, that's a secret. I said, it's the worst case secret in the world. But anyway, so they said, yeah, we're not doing a physical launch. We're not going to go to a hotel and have a convention. We're going to do a virtual launch over the web. I said, it sounds exciting. That'll work. So I said, so why are you calling me? They said, well, what we're going to have, they said, this virtual launch is going to be awesome. We're going to have like 50 big people from the industry. They're going to do short videos about how things work. And it's going to be great. I said, that's terrific. They said, well, we want you to do one of them. I said, really? You want, like, me? You know who you're talking to, right? I mean, you want me to do one of these? And they said, yes. And I'm thinking, this is 2012. I'm saying, so you want me to talk about the new stuff in Active Directory or networking or, I don't know, storage, the things that people actually read about me doing? They said, no, we want you to talk about shared nothing live migration in Hyper-V. And I said, do you want me to do that because of all the articles I have not written about Hyper-V? Or maybe the books that I've not written about Hyper-V? They said, no. Team wants you. We know you're going to be great. So I drop everything. I build myself, and I don't have like extra machines lying around. I'm busy studying because I'm going to start teaching classes and writing books about Server 2012. So I had an old T61 ThinkPad laptop and this ancient compact, I don't know, DL-1 server. Plug these suckers in, and I got them on an Active Directory, and I checked this stuff out over and over. I got to do it in my sleep, because the Microsoft guys didn't really tell me what they wanted me to do. And so I got there, and I'm going to be doing the video stuff, and I'm in Seattle, which is 3 hours different from where I live. And so I get up early. I'm an early riser anyway, so it's 3 a.m., and I'm remote desktoping to my thing in Virginia, 3 time zones away. Just doing my failovers, everything's totally awesome. But this is failover without a cluster. That's what that shared nothing is. I said, I should build a cluster. Yeah, I've not gotten around to building a Hyper-V cluster. So I remotely create a file share, stick the VHD in the file share. I got old and new running. I'm failing those babies over one way, and that's totally awesome. I said, what I need now is I want to see disaster recovery time. So I reach over, and I got the virtual machine on old, and news backing up, and I shut off old with remote desktop, and it fails over smooth as like silk. I'm like, that is awesome. I am the man. That's when I realized that in 6 hours I had to demonstrate this, and I had turned off a machine that was 5,000 kilometers away. As it turns out, my arms are not that long, but I do have a neighbor that can take whatever instructions. Give me another minute, please. I never got to talk at NIC before. I hope that I've satisfied you guys. I hope that this has really been a good thing for you guys. To that end, I get to come here because you asked for me, so it's time to do an evaluation. So please don't forget me on that. Other than that, you can find me at mminasi. Twitter is a great way to find me. I'm at help@minasi.com. And I just want to say enjoy the rest of the show. And remember to use this knowledge for good and not for evil. Thank you, thank you, thank you. Is anybody going to try this? Anybody going to build a cluster? Come on. All right. Email me. Tell me how it works. Wait, blow up a whole system, you fool.